This is the fourth video about graphing polynomial functions. In this video, we're looking at how to write an equation when you're given a graph. Let's get started. Before we look at an example where we go from a graph to an equation, I want to practice one specific skill. Let's assume that we have used our x-intercepts to find these factors with the multiplicities based on if it crosses or bounces at different x values on the graph. Okay? And our goal right now in this example is to figure out if there's a leading coefficient or what that leading coefficient might be. And the way we do that is by using the y-intercept. Keep in mind that the y-intercept is where the graph crosses the y-axis, which may be obvious. But at this specific point, I know that x is 0 and y is 32. Okay? So I'm going to copy down this function and I'm going to plug x 0 into x. Now when x is 0, then y is going to be 32. So I'll plug in here 32 because that's what y is when x is 0. Okay? Now doing some algebra on this side, or arithmetic, 0 minus 1 is -1. 0 plus 2 is 2 squared. And 0 plus 4 is 4. So 32 is equal to, let's see here, 2 squared is 4, times -1 is -4. -4 times 4 is -16. So I get -16a. And then to solve this, I divide both sides by -16. And 32 divided by -16 is -2. So the function is this function with that leading coefficient a plugged in. All right, and we get f of x is equal to -2 times the quantity x minus 1 times x plus 2 squared times x plus 4. All right, let's look at one example where I go from the graph to an equation. Our first step is to use the x-intercepts and the multiplicities to find some factors of this graph. Okay, I'll start f of x is equal to some leading coefficient. Okay, we'll come back to that later. Okay, and reading off these, right here, I know that I have a factor to get -3 as a root or a 0 or an x-intercept. I have x plus 3 must be a factor. Now at that point, the graph crosses the x-intercept, and so that must have a multiplicity of 1 because it just crosses very cleanly. It doesn't like kind of do a wiggle as it goes through the x-intercept. Okay, at this x-intercept, the factor I would need to get -2 as a 0 would be x plus 2. Okay, now at this one, I notice that it doesn't cross, it bounces, right? And it bounces, I've learned, happens when I have an even multiplicity. Okay, and that looks like it's pretty smooth, not like extra wide, and so it's going to have multiplicity of 2, a smaller even number. Okay, and then finally at this 0, the factor I would need to get a 0 at +1 would be x minus 1. Okay, and now this crosses through it, which means it has an odd multiplicity, and it just crosses through very cleanly without any extra curvature, and so it must have a multiplicity of 1. Now, typically we don't write in an exponent of 1, so I'll go ahead and erase these, but that's kind of how I thought through those problems. Okay, that's going from the x-intercept zeros to finding factors to doing a lot of the work to find this function. Now what I'm left to do is to figure out the value of this a term. And as I said previously in this video, we figure that out using the y-intercept. Okay, I know that when x is 0, y is 6. So I'll first plug into 0 into all of my x terms. All right, and when x is 0, then y must be 6. Okay, so simplifying a little bit here, I have 0 plus 3 is 3. I'm going to go 0 plus 2 is 2. 2 squared is 4. And 0 minus 1 is negative 1. Now, 3 times 4 is 12. Times negative 1 is negative 12 times a. And then I will divide both sides by negative 12. And so a must equal 6 divided by negative 12 is negative 1/2. So the function that would give us this graph is f of x equals negative 1/2 x plus 3 times the quantity x plus 2 squared times x minus 1. So we pulled that basically from the x and y intercepts. Now, before we finish, before we say, yep, I am totally done, this is my answer, moving on, okay? I think it's really helpful to double check our answer based on end behavior. So looking at the end behavior here, this is going down and down, okay? And I know from my video on end behavior, that happens when I have an even multiplicity. So looking at here, I have 1 and 2 and 1. And so 1 plus 2 plus 1, I mean, I can do that because these are just single x values, okay? 1 plus 2 plus 1 is 4, which is what our question said, okay? Which is an even multiplicity. And my leading term here is negative, which means my end behavior is down, down. So it looks like this end behavior agrees with this function. So I'm pretty confident now that this actually is the function that would give us this graph. So this video is about writing equations when you're given graphs, mostly using the x and y intercepts, but using the end behavior to double check our final answer. Thank you for watching.